Hey class, factoring day 2 is a combination of what we did the first day of factoring and then greatest common factor and some factoring with special patterns. So first, remember factoring is the reverse of multiplication. So before, when you have 5x times 3x minus 7, if you multiply 5x times 3x is 15x squared, and 5x times negative 7 is negative 35x. So that's multiplying. And then reversing it is factoring. So in factoring, you have to say, okay, well, what can I divide both 15 and 35 by? I can take out a 5. And then what can I divide both x squared and x by? I can divide both by x. So if you divide this by 5x and this by 5x, the 5x goes out in front. And then 15x squared divided by 5x would be 3x. And 35x divided by 5x would be negative 7. And so that's going backwards, factoring. When we factor out a single factor like that, like a 5 or an x or a 5x, that's called a greatest common factor. It is the largest number or variable that you can take out. Or that you can, largest number of variable can divide all by. The greatest common factor. Okay, the before here and after factoring, that's kind of what we went through in the day 1 video. So today, the greatest common factor idea is a little bit new here. We also have special factoring patterns. This one is difference of perfect squares. Difference means subtraction. Perfect squares are x squared, 4, 9, 16, 25, 36, all of those perfect squares because 1 is a perfect square, 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25, 6 times 6 is 36, 7 times 7 is 49, 8 times 8 is 64. Okay, you get the point. Those are all perfect squares. The 1, 4, 9, 16, 36, 49, 64. Also, x squared is a perfect square, x to the 4th is a perfect square, y squared is a perfect square, etc. So to factor, if you have difference of perfect squares, which means you have a squared minus a b squared, it will always factor to a plus b times a minus b, or a minus b times a plus b. You can write those factors in either order. So you do have to know your perfect squares though. 121 is 11 squared. So this one would factor to 11x plus 4, the square root of 16 is 4, and 11x minus 4, because this is a squared minus b squared, where a is 11x and b is 4. Here, a squared minus b squared, a would be x and b would be 5, the square root of 25. So this would factor to x plus 5 and x minus 5. Notice when you multiply this back out, you'd get x squared minus 5x plus 5x and then minus 25. So in difference of perfect squares, the middle terms equal 0. So that's why it factors like that. One's positive, one's negative, so they cancel out. Kind of like multiplying complex conjugates. Here, a squared minus b squared, since 4 is a perfect square and so is x, and then 9 is a perfect square. The square root of 4x squared is 2x, the square root of 9 is 3, so 2x plus 3 and 2x minus 3. A squared minus b squared again, where you have x and 3 as your square roots, and you can write that the minus first if you want. It can be x minus 3 times x plus 3. It doesn't matter which way you write the parentheses in order there. Perfect square trinomials. Now, perfect square binomials, these ones, you should definitely memorize this pattern. It's going to save you some time. Now, perfect square trinomials, you don't necessarily need to memorize this. But if you do see this pattern, especially, if you recognize that, hey, both of the beginning numbers are perfect squares, 4 and 9, I would try this first. So if they're both perfect squares, you're going to have, 2z and 2z to make 4z squared. And then 9 is 3 and 3. Since it multiplies to be positive 9 but adds up to negative, you're going to have two negative factors because -3 and -3 will make positive 9. Then you can easily check it by checking the outside, and that's -6z, and the inside, and that's -6z. So that is our factors. And perfect square trinomials, like we did with completing the square, then this would factor to 2, or you can write this as 2z minus 3 squared. So it's a perfect square trinomial where a is not just 1 in that case. So this one, I'm noticing again 36w squared and 25 are both perfect squares. So the square root of 36w would be 6w. So in both, and the square root of 25 is 5. And then it multiplies to positive 25, adds up to positive 60, so both of these have to be positive. Just multiply it out to check. 30w, and the inside is 30w, and so it does add up to 60w, so that is your answer. Now the perfect square trinomial equation is if you have a squared plus 2ab plus b squared, then it factors to a plus b squared. And if you have a squared minus 2ab plus b squared, then it factors to a minus b squared. So we can rewrite this as 6w plus 5 squared. But these formulas are not necessary if you just guess and check or try what I showed you, just thinking about it. No use trying to memorize a formula with a bunch of variables that you probably won't remember later. Okay. When factoring, the first step you should always do is to look for what's called the greatest common factor. So if you can take out a factor of 2 or factor of x before you factor it more, you should always do that first. So for example, in this one, 4x cubed minus 2x squared minus 6x. Notice that I could divide all of these by an x, which means x is my greatest common factor. So I'm going to take that out front. So it'll be x times 4x squared now, I took out an x, minus 2x, because there was 2, I took 1 out, and then minus 6, I took that x out. When I take it out, it goes out in front because it's the reverse of multiplying. So I should be able to distribute this back through and equal what I had originally started with. Then let's see if I can factor this any further. So if you want to guess and check, you would start by your parentheses. It's a -6, so you know that you have to have one positive and one negative factor. 4x squared though, so you could either have 2x and 2x or 1x and 4x. So I'm going to do it with the box. I'm going to put the 4x squared here and the -6 here. Then we multiply. 4 times -6 is -24. And it has to add up to -2. So 1 and 24, 2 and 12, 3 and 8, 4 and 6. 4 and 6 I can make 2 with. The 6 will have to be negative though to get the -2. So then I put 4x here and -6x here, or vice versa. Then look at what does 4x squared and 4x have in common. They both have a 4x, so I'd put the 4x in that row. Then 4x times 1x gives me 4x squared, and 4x times 1 is 4x, and x times -6 would be -6x. So guessing and checking method, you would have started with, okay, I know it's 4x and 1x. I know that I have to have one positive and one negative. I have to use the numbers that multiply to 6. So you would have had to use 1 and 6 or 2 and 3. You would have said, okay, if I put the 4 with 1 and the x with 6, then I can get 4x and 6x, which will add up to -2. Make the 6 negative and the 1 positive, which is what you get right here with the box method, 4x minus 6 and x plus 1. 4x minus 6, x plus 1. So here's our answer for the first one. Second example, 6y to the 4th plus 3y squared. First, 6 and 3 are both divisible by 3. Then y to the 4th and y squared, I can take out 2y, so y squared from each. Which means if I take out a 3y squared here, 6 divided by 3 is 2. Y to the 4th, take out a y squared, will be y squared left. Then divide this one by 3y squared. 3 divided by 3 is 1. Y squared divided by y squared is 1. That's my answer. If I multiply that back out, distribute that 3y squared back in, I should get what you started with, the 6y to the 4th plus 3y squared. 2y squared plus 1 does not factor any further. 3x squared minus 12. I can divide both 3 and 12 by a 3. I can't take out an x since the 12 doesn't have an x, but I can take out a 3. That would leave me with, divide both these by 3, and x squared minus 4. Now hopefully you recognize that this is an a squared minus a b squared, because x squared is perfect square and so is 4, and you're subtracting. So that's going to factor to x plus 2 and x minus 2. Pause it if you need some more time. 6x cubed minus 15x squared minus 9x. So we can take out a 3 and an x, because 6, 15, and 9 are all divisible by 3. X cubed, x squared, and x are all divisible by x. That leaves me with, divide this one by 3x, and I'm left with 2x squared. Divide this one by 3x, and I'm left with negative 5x. And the last one by 3x would leave me with negative 3. Now let's see if I can factor what's left here. An easy way to tell is to take a times c, which is negative 6, and can I find anything that multiplies to negative 6 that adds up to b, which is negative 5? And I can. That'd be positive 1 times negative 6. So that means it is factorable. You can use that information to factor using the box too. So you put your 2x squared here and your negative 3 here. The box method, like I said, is my preferred method, so that's what I'm going with here. Then you put these in your diagonal, 1x and negative 6x. Then you fill out the outside of the box using those numbers. So to get 2x squared, here, what do 2x and 1x have in common? Just a 1x, which means my 2x has to go up here. So 2x times 1x is 2x squared. Then 1x times 1 is 1x, and 2x times negative 3 is negative 6x, which means that this one factors to 2x plus 1 and x minus 3, and then a 3x out front. You could have used guess and check, and that would have worked just fine. 2x squared, so 2x and x. And then you would have looked at factors of negative 3, which are just 1 and 3. Multiplies to negative 3, adds up to negative 5, so your bigger one has to be negative. So I would have put the negative 3 with this one to make this negative 6x, and I would have put the 1 with the x to make this a 1x, and then that would have added up to negative 5x. And so guess and check works too. Let's see here. A couple more. 7m squared plus 9m. The only thing these two things have in common is an m. So if I take an m out, I'm going to have 7m plus 9 left. Now this factor here is linear, It's an exponent of 1, and that means that it doesn't factor any further. It can only be factored if there's a greatest common factor. So you're done. And the last one, 3, 27, and 24 are all divisible by 3. So that would leave me with x squared minus 9x plus 8. Since this is an x squared, I know it's going to be x times x. Since it multiplies to positive and adds up to negative in the middle, they're both going to be negative. So what multiplies to 8 but adds up to 9? Well, 1 times 8 is 8, and 1 plus 8 is 9, so it'll be -1 and -8. The box is not necessary when your leading coefficient for A is 1 because it has to be x times x. You have no other choices. So that is the answer. All right, factoring.